they told constant pressure, we have to take it at CV only.
Yeah, ma'am, because of so the question is related to thermodynamics. Is it right? Okay. And critical temperature, critical pressure, one concept it is there. So based on the critical temperature and critical pressure, so we can find out the atomicity of the molecule. That is only we can call as a Cp and Cv value. Gamma is equal to Cp by Cv, some formula is there. Gamma is
Yes, sir,
equal to Cp.
I understood, but they said constant pressure. So I assume we have to take CP at constant pressure. But
No,
they
no,
took
no, no,
C.
no. Cv value. Okay,
Then
we
when
had
they
taken
said
as a Cv.
constant pressure, why did they take it, the constant volume, sir?
So 1 second, is the question again. Question is 7 moles of the certain monoatomic ideal gas under a temperature increase of the 40 Kelvin at a constant pressure. The increase in the internal energy of the gas in this process is
Sir, because they gave an option for the thing when we take constant pressure also. So I would have ticked that and then I would have lost a mark.
okay. So if you take constant pressure means what you are getting the answer?
5180, sir. But the answer is B.
They're taking the volume also constant, na? They didn't mention the volume here. 7 moles of gas, certain monoatomic gas goes under temperature increase of the 40 Kelvin and constant temperature, and the internal energy. They didn't talk about the volume. I think so. Volume also it is the constant. That's why they had taken as a volume CV value at a constant pressure and constant volume. Got Kathy?
Yes, sir. Got it.
Okay. So they didn't give any volume here. Okay. Actually, equal volume of the gases is or equal number of moles. V is equal to N. It is there. V is equal to N. Number of moles are going to be increases means volume is going to be increases. But if we increase the temperature means, okay, so number of volume is not going to be changed now. Got the point or not? V is that according to the Avogadro's law. Okay, so for that reason they had taken it is as here constant volume. Got the point?
Yes, sir. Got it.
Okay, so then next. So all of you read preparation of the haloalkanes, and have you solved any questions from JEE previous years? Hmm?
Sir, I don't have the material, so I didn't solve any, but I went through the notes.
Okay, so you don't have any material, Aditi? Aditi, you are from resonance, na?
No, sir, Chitra. Like, actually, I'm out of station right now, so I didn't bring any extra materials.
Okay, then no problem. Then no problem, Aditi. So after coming home, just you can solve these questions here. Okay,
Yes.
then what about others?
I,
What about others?
I went through the notes and solved a few questions from the materials, sir. I didn't do the previous papers. I thought like once the chapter would be completed, then I would go through it.
Okay, so you're getting the answers, Ritu, from your material.
Yeah, sir. A bit confusing, but yeah, I'm getting.
Okay, then what about Kathy? Kathy, are you getting answers or not?
Sir, I still haven't tried anything. I will try after you complete chemical properties, sir.
Okay. So, okay, right. But better you'll do preparations and isomerism also be completed. So based on that one only, we have a more number of questions.
Yes, sir. Those
Again,
I did.
yeah. Okay. So better we will go that one. So it will complete after completing of the concept. If you have done some questions, which you will get some idea. Okay. For that reason only I'm asking here. Right. Next. So we'll go for the preparation of aryl halides. Now we had seen the preparation of alkyl halides. Now we will check it out the preparation of the aryl halides. Okay, so we can go for here, preparation of aryl halides. Preparation of aryl halides. Okay, simultaneously I'll go over here. The preparation of aryl halides. So how we are going to prepare the aryl halides? What is the best example for the aryl compound means here? Benzene. So benzene is one of the best compound for the aromatic compound. Okay, so when the benzene is treated with chlorine in presence of AlCl3, it forms as a chlorobenzene. Okay, it forms as a chlorobenzene plus byproduct is here HCl. Okay, this is the one preparation. So that means the given reaction is example of the electrophilic substitution reaction. The given reaction is electrophilic substitution reaction. Okay, so that means hydrogen is replaced by the chlorine. Hydrogen, it comes outside in the form of here H plus. That H plus is replaced by the Cl plus ion. Okay, and what is another reaction means here? So Sand-Meyer reaction one it is there. So anyone you are having idea about the Sand-Meyer reaction? Sand-Meyer reaction. Same reaction again we are going to study under the amines chapter. Amines chapter also. Chemical properties of the amines also we are going to study here. By the Sand-Meyer reaction also we are going to prepare the aryl halides here. So first of all, what is mean by the Sand-Meyer reaction? So what is mean the Sand-Meyer reaction means aniline. What is the molecular formula of the aniline on benzene ring? If NH2 group it is there, means that we can call as a aniline. Okay, NH2 group it is there, means that we can call as a aniline. So when the aniline is treated with sodium nitrite or nitrous acid, okay, aniline is treated with sodium nitrite or nitrous acid in presence of HCl, at 0 to 5 degrees Celsius, at 0 to 5 degrees Celsius, or if you take in Kelvin formation, how much temperature we can take as here? 273 okay, 278 Kelvin temperature. How much temperature here? 273 to 278 Kelvin temperature. Okay, when the aniline is treated with sodium nitrate and nitrous acid in presence of HCl at 273 to 278 Kelvin temperature, it converts into benzene diazonium salt. How it is going to be converted means here, it converts into benzene diazonium salt, Cl minus and N plus here. Okay, so whatever the product it is forming, the Sand-Meyer reaction, so that we can call as a benzene diazonium chloride. Benzene diazonium chloride. Benzene diazonium chloride. So by using the benzene diazonium chloride, so we are going to prepare the aryl halide. Okay, so in this one, what are the reagents we are taking means here? For example, cuprous chloride is that when the benzene diazonium chloride is treated with cuprous chloride in presence of HCl, it forms as a chlorobenzene. It forms chlorobenzene, Cl. When the benzene diazonium chloride is treated with cuprous chloride in presence of HCl, it forms as a chlorobenzene. Similarly, if it is treated with cuprous bromide, Cu2Br2 in presence of HCl, Cu2Br2 in presence of HCl. So what is the product it is forms means here? It forms as a HBr. Okay, it forms as a bromobenzene. It forms as here bromobenzene. Okay, sir, what are the byproducts it forms means here? Nitrogen gas it forms as a byproduct here. So which one is going to be replaced here? If you see on benzene diazonium chloride, on benzene ring N2 group and Cl minus it is there. Okay, in this one, in place of Cl, so if you take cuprous chloride means you will get as a chlorine is going to be substituted on benzene ring. If you take HBr means so bromine is going to be substituted on benzene ring, and byproduct forms as a HCl here. Okay, and by using this method we cannot prepare as iodides. Okay, by the Sand-Meyer reaction, what are the cuprous iodide? We can't use as a cuprous iodide. In place of cuprous iodide, what we are taking means here alcoholic potassium iodide we are taking. Okay, we are adding as a potassium iodide. And if it undergoes to the reflex reaction, it undergoes here reflex. So what is meant by the reflex means heating at high temperature for a long time is called as a reflex. When the benzene diazonium salt is reacts with the potassium iodide, it forms as a iodobenzene. It forms as here iodobenzene. That means iodine plus N2 plus KCl is the byproducts. Okay, by using the Sand-Meyer reaction, that means by using the cuprous iodide, we cannot prepare as a iodide. So which one we are preparing or which one we are taking means here alcoholic potassium iodide only we are taking. So which one we are taking here? We are taking as here alcohol aqueous solution of potassium iodide. Aqueous solution of potassium iodide. And if you do the reflex mix, it comes as a iodobenzene. Now you got the clarity. Still anyone you are having doubt here? So I may get the doubt here. I think so somebody they'll get the doubt. Sir, why we are not using as a cuprous iodide? Why only we are taking the potassium iodide? That is the question. Any one of you having that kind of question?
Yes, sir.
Very good, Aditi. Aditi, in 11th standard, we studied some concept. Did you remember Fajan's rule 1? It is there.
Yes, sir.
Fajan's rule is explains the covalent character or ionic character, Aditi.
Sir, it explains about the ionic character of a covalent bond or covalent character of an ionic bond.
Very good, Aditi. Okay. So, as per that one, now you can check it out, Aditi. Here, cuprous iodide is a covalent or ionic. So we have some condition. If the size of the anion is going to be increases, covalent character
Yes,
is going
sir.
to be.
So both of them
Size
are
of
big, right? Like copper is a
copper,
big cation and
copper is big, ma. Across the period, size is going to be decreases or increases, ma.
okay, it
Across
decreases.
the, because of it is the transition element, D block element. Across the period, size is going to be decreases, na.
Yeah, sir.
Okay, if the size is going to be decreases and iodine is having the greater the size, smaller the size of the cation, greater the size of the anion, then what about here? So which bond it will be present in between the cation and anion?
Covalent, right?
Covalent. Okay, so that's why here we cannot use as here. So cuprous iodide. But potassium iodide is completely ionic in nature. If it dissolves in a water, means it undergoes the ionization, it forms as a I minus and K plus clearly. So due to that reason only we can't use as a cuprous iodide. In place of cuprous iodide, we are using as here aqueous solution of the potassium iodide. For the clarity, still any doubt is there? Okay, right. So next, Getterman reaction one it is. So by using the Getterman reaction also we can prepare as here the alkyl halide. Aryl halides we are going to be prepared. So what are the aryl halides we are going to be prepared by using the Getterman reaction? Means by using the Getterman reaction we can prepare only um, chlorobenzene and bromobenzene. Okay, so which one we can prepare means here we can prepare only chlorobenzene and bromobenzene. Clear? Now let us see the Getterman reaction. Getterman reaction. Okay, so what is mean by the Getterman reaction means here also we are taking as a benzene diazonium salt. Here also we are taking as here benzene diazonium salt. What is the molecular formula of the benzene diazonium salt? Means on benzene ring. If NH2Cl it is that means that we can call as a benzene diazonium salt. Okay, N2Cl, Cl minus plus here. Okay, so when the benzene Getterman reaction, benzene diazonium salt, benzene diazonium salt. diazonium salt. Okay, so benzene diazonium salt is treated with copper in presence of HCl, copper in presence of HBr, copper in presence of HCl, copper in presence of HBr. It is that. If you take copper in presence of HBr, means it forms as a chlorobenzene. Copper in presence of HCl. Copper in presence of HCl means it forms as a chlorobenzene plus N2. Okay, and copper in presence of HBr means it forms as a bromobenzene. It forms bromobenzene. So Br plus N2 is going to be formed. So if you see these two are, it look like as a similar only. These two are, it look like as a Sand-Meyer reaction and Getterman reactions are, both are, it look like as a similar only. But only the thing is reagents are different. So what are the reagents we are taking in the Sand-Meyer reaction? What are the reagents we are taking here? So we are taking as a cuprous chloride or cuprous bromide here. Okay, so cuprous chloride or cuprous bromide we are taking here. In Getterman reaction, what we are taking? So catalytic halo acids we are taking. That means copper, it act as a catalyst in these reactions. Which metal it act as a catalyst means here? Copper metal it act as a catalyst. Copper in presence of HCl, copper in presence of HBr. Copper in presence of HCl, copper in presence of HBr means it forms as a chlorobenzene and bromobenzene. Now we got the clarity. Okay, and we have another method. So that is a named reaction. Bage-Schiemann reaction. Okay, somebody they used to call as a Bage-Schiemann reaction. Okay, so Bage-Schiemann reaction or Bose-Schiemann reaction here, right? So by using that method, we can prepare as a fluorobenzene. Bage-Schiemann reaction. C-H-I-E. C-H-I-E-M-A-N-N. Bage-Schiemann reaction. Bage-Schiemann reaction. Bage-Schiemann reaction. So by using this method, we can prepare as a aryl fluorides. Aryl fluorides. Aryl fluorides. Okay. So we cannot prepare the fluorides directly. Okay, we cannot prepare here fluorides directly. So how we are going to prepare as a fluorides means here by using the benzene diazonium salt. When the benzene diazonium salt is treated with tetrafluoroboric acid. When the benzene diazonium salt is treated with tetrafluoroboric acid. So what is the molecular formula of the tetrafluoroboric acid? Molecular formula of the tetrafluoroboric acid, HbF4. So this we can call as a tetrafluoroboric acid. Tetrafluoroboric acid. So when it is treated, benzene diazonium salt is treated with tetrafluoroboric acid, it forms benzene diazonium tetrafluoroborate is going to be formed. Okay, so what is the intermediate it is going to be from here? Benzene diazonium tetrafluoroborate. Okay, so byproduct is it forms as a HCl. Byproduct is it forms as a HCl. Again, so benzene diazonium tetrafluoroborate. Fluoroborate is highly unstable. Again, it undergoes to the decomposition reaction. Again, it undergoes to the decomposition reaction, and finally, it forms as a fluorobenzene. And finally, it forms as here fluorobenzene plus nitrogen plus BF3 is going to be formed. Okay, so by using the Bage-Schiemann reaction, so what is the product we are going to be preparing here? We are going to prepare as a aryl fluorides. Aryl fluoride directly cannot be prepared. How we are going to prepare as a aryl fluorides means by using the benzene diazonium chloride. When the benzene diazonium chloride is treated with tetrafluoroboric acid, it forms benzene diazonium tetrafluoroborate. Benzene diazonium tetrafluoroborate is highly unstable. By heating slightly only, it undergoes to the decomposition reaction and finally it forms as a fluorobenzene. Now you got the clarity, all of you? Still anyone you are having here in the preparation of haloarenes? Okay, so these are the reactions we are having. Clear? Until here, anyone you are having doubt?
No, sir.
Okay.
No, sir. Got it.
Okay, so then I'll go for the physical and chemical properties now. Sangeeta is absent, huh? Okay, right. No. So we'll go for the physical properties now. Okay. So already knows the physical properties. What are the physical properties of the haloalkanes? Both mixed together we'll see now. Physical properties of the haloalkanes and haloarenes. Physical properties. Physical properties of the haloalkanes and haloarenes. Okay, so first point here, lower alkyl halides are colorless gases. Okay, and up to C18 are colorless liquids with sweet smelling here. Okay, and after the C18, greater than C18 carbon atoms are colorless solids with characteristic smell here. Okay, so what are the more than C18 carbon atoms? All those alkyl halides are colorless solids with some characteristic smell. And similarly, if you take here aryl halides, what about the aryl halides? Aryl halides are colorless liquids with characteristic smell. Okay, aryl halides are so colorless liquids with the characteristic smell. Now, second point here. So what about the solubility, ma? Is haloalkanes and haloarenes are soluble in water or insoluble in water? Haloalkanes and haloarenes. Is haloalkanes and haloarenes are soluble in water or insoluble in water? All of you.
Sir, are they insoluble in water?
Yes, ma. It is all haloalkanes and haloarenes are insoluble in water. Aditi, how you are telling that haloalkanes and haloarenes are insoluble in water? What is the reason?
Sir, because like we use this, I forgot the compound name. We use it, the chlorine compound for dry clean, right? It's a non-polar solvent. So how will it mix with water? Because we use it for removing oil stains and all, right? So
Right.
I just thought.
Simple logic here. So which we can call as a actually polar is there, non-polarity is there. Okay. So if you see whatever the compounds are there, aryl halides or alkyl halides, they are covalent in nature. They are not in ionic in nature. Okay. Haloalkanes and haloarenes here. So both are covalent in nature. So most of the covalent compounds are insoluble in water. Most of the covalent compounds are insoluble in water. Okay, for that also I'll give one clarity to you. If you see glucose is a covalent compound or ionic compound? Glucose, urea, Ritu.
Sir, it's covalent, but they are soluble in water.
Why it is soluble in water? If it is now water, before that only I had given one statement. Covalent compounds are insoluble in water. Covalent compounds are insoluble in water. But you are telling that glucose is a covalent compound. But even the glucose is going to be soluble in the water. Why it is soluble in the water? That is my question. Ritu? Kathy?
I'm not sure, sir.
Okay. Ritu?
I'm also not sure with it.
Simple logic, ma. Already you know the structure, glucose structure. If you see glucose structure, how many OH groups are there? 5 OH groups are there in glucose. Okay. Number of hydrogen bonds are increases. Their solubility also is going to be increases. Urea. Urea also it forms as a more number of hydrogen bonds. Due to that reason only urea is going to be dissolved in a water. Got the point or not? Number of hydrogen bonds are increases, their solubility also is going to be increases. And one more example I'll ask here. Alcohols are there. Alcohols we are calling by alcohols. Okay, sir, you forget about that one. So, sir, what is it? Just you tell me the known example. We don't know whatever you're telling that about that one means. Yeah, I'll tell one example. Phenol. Have you seen Dettol, everyone? While discussing the
Yes,
introduction
sir.
part, clearly I told that.
Yes, sir.
Dettol is containing 4% of the phenol. Is it right?
Yes, sir.
Now,
Yeah.
Dettol is containing phenol. So, if you place the Dettol in water, means it is either it is dissolving or not.
Yeah, it
Okay.
gets dissolved.
So why it is going to be dissolved means here because of it forms as a hydrogen bonds. Actually,
So
so
is it because of hydrogen bonding?
yes, so because of it is hydrogen bonding only. Okay, so number of intermolecular hydrogen bonds are increases, their solubility also is going to be increases. And one more point you read or not, I don't know exactly here. So one water molecule it forms as a 4 hydrogen bonds. One water molecule it forms as a 4 hydrogen bonds. Like that, number of hydrogen bonds are increases, their solubility also is going to be increases. Got the clarity? Got it, everyone? Number of hydrogen bonds are increases, their solubility also is going to be increases. Okay, so due to that reason only glucose and urea are highly soluble in a water. Okay, but others are there insoluble in a water. Fatty acids are there. Fatty acids are going to be dissolved in a water. All fatty acids are there covalent compounds only. So what is the fatty acids which we can consider as a fatty acids? Oils, vegetable oil, okay, vegetable oil, and cholesterol also we can call animal fat here. Okay, all those are insoluble in your water. Oils are there. Oils are also it is a covalent in nature, but they are insoluble in water. Okay, so why this one only they are highly soluble means here. So because of they form as a hydrogen bonds, and here also haloalkanes and haloarenes are insoluble in water. Okay, haloalkanes, haloalkanes, and haloarenes, haloarenes are insoluble in water. Are insoluble in water. Okay, so why they are insoluble in water means because of they are the covalent compounds. Covalent compounds are insoluble in water, but highly soluble in organic solvents. But highly soluble in organic solvents. But they are highly soluble in organic solvents. Now you got the clarity. Next. So what about the boiling point temperatures? Do you have any idea about the boiling point temperatures? Boiling point temperatures. Do you have any idea about the boiling point temperatures? Here, haloalkanes. If the surface area is going to be increases, their boiling point temperature is going to be increases. Okay, so last time also, I think so either we discussed or not exactly, I didn't remember here. For example, here first, what is the statement means? Boiling point temperatures are depends upon the surface area. Depends upon surface area. Surface area. Surface area is going to be increases. Surface area is increases. Boiling point temperature also. Boiling point temperature also increases. So what is the best example for that one means here? N-butyl chloride. I can take as a 1-chloropentane that I'm going to write like this here structures. 1, 2, 3, 4, 5. Chlorine it is there. So this one is the one structure, and another one is I'm writing like this. So now which one is having the greater the boiling point temperature? So this we can call as a N-pentyl chloride. N-chloropentane. N-chloropentane. Isochloropentane. Or better you write as IUPAC name here. Name is not going to be set here. Okay. N-pentane, isopentane, neopentane. N-pentyl chloride, isopentyl chloride, neopentyl chloride. Now I got the clarity. N-pentyl chloride, isopentyl chloride, neopentyl chloride. Which one is having the greater the boiling point temperature? That is my question. Here
Sir,
I
is
had
it the
given three.
first?
Ma? Which one?
Is it the first N-pentyl chloride?
N-pentyl chloride. So why the N-pentyl chloride is having greater the boiling point temperature?
So because it has less number of substituents like chains
Okay.
attached to it, so
Oh.
it has a larger area.
Very good one. Okay, larger area. If the larger area is increases, what happen, Aditi?
So more the larger area, more the boiling point. And as the area decreases, the boiling point also decreases.
Very good, Aditi. Here actually how we can define means here. Let's see, I had given three structure. So one is the N-pentyl chloride, isopentyl chloride, neopentyl chloride. Okay, which one is having the greater the boiling point temperature means N-pentyl chloride is having the greater the boiling point temperature than that of the isopentyl chloride, then that of the neopentyl chloride. Okay, so here N-pentyl chloride. Why the N-pentyl chloride is having greater the boiling point temperature means because of more surface area. Surface area is increases, their van der Waals attraction forces also is going to be increases. Surface area is going to be increases means, okay, their van der Waals attraction forces also is going to be increases. Okay, if the van der Waals attraction forces increases means here we need more energy to break the bonds here. So due to that reason only, okay, so N-pentyl chloride is having greater the boiling point temperature than that of the other one. Okay, and similarly how we can write is here another step here. If the branched chains are increases, if branched chains are increases, so boiling point temperatures are decreases. Boiling point temperatures are here decreases. The branched chains are going to be increases means boiling point temperatures are going to be increases. Now you got the clarity. Same concept. So we can apply for the haloarenes also. So if you see haloarenes, how was the boiling point temperatures? So generally we are taking as a dihalides. So 1,2 dichlorobenzene, 1,3 dichlorobenzene, and 1,4 dichlorobenzene. And that is also we can call as a simply orthodichlorobenzene, metadichlorobenzene, and paradichlorobenzene here. Okay. So which one is having the greater the boiling point temperature? Here, orthodichlorobenzene it is there, and metadichlorobenzene it is there. Cl bond Cl, and paradichlorobenzene it is there here. para